Hey everybody, it's Mr. Oaks. I'm here now we're going to talk about using the Pythagorean theorem to actually then find the distance formula. Now the distance formula is basically what we call a derivative of the Pythagorean theorem, where we use that when we have coordinate points on a graph. So it's very similar because it's based off of the Pythagorean theorem. But first we're going to look at a problem right here. The figure shows a right triangle, and we want to approximate the length of the hypotenuse to the nearest tenth. So I'm going to use my calculator. Okay. So the first thing I need to do is figure out, well, how long are my sides? Okay. Now it's a little difficult to see because it's smaller. It's a smaller thing here. But when I look along the bottom, and I'm going to call that A. Okay, oh, you can't even see that. I'm going to call that A. That's a little closer. But I see that this has a length of 1, 2. So that's 2 there. So A is going to be 2. So I'll leave them right over here. A equals 2. And when I look over here, I'm going to call this side B. I've got 1, 2, 3, so that's 4. So I'm going to write 4. So B equals 4. Okay. So as always, I'm going to start off. All right. So I'm going to write C there. As always, I'm going to start off by first writing the formula. So we have A squared plus B squared equals C squared. Okay? And I'm going to plug my numbers in. Okay? So A is 2, so I have 2 squared, plus B is 4, so we have 4 squared equals C squared. Okay? So we got 2 squared. 2 squared is 4. 4 squared. 4 squared is 16. Equals C squared. Okay. 4 plus 16, obviously, it's simple addition. It's 20. Okay. So 20 equals C squared. Okay. But now I need to take the square root because I just want to know the length of C. Okay. So I'm going to go and put my square root symbols around. Okay. And I get that C is going to be equal to, and I'm going to go to my calculator, and I'm going to put in, well, I've got 20, so I'm going to hit second. I'm going to go to my x squared button because right above it is my square root symbol. Hit that. And then I'm going to put in 20. And I get this big long number here. 4.472135955. But I don't need that whole thing. All I need is to the nearest tenth. So again, when I look, I gotta look. The number that's right after the second 4 is a 7, and that's going to cause it to go up. So it's going to round up to 4.5. Okay. Now, I have a grid. I have grid paper so I can actually count the number of spaces. So a lot of times that's what I'm going to do. I'm going to kind of try to make a right triangle and then count the sides and then use it to then use the Pythagorean theorem. But sometimes they're just going to give you points, and that's when you're going to need to use this distance formula. But I want to show you how that comes about from the Pythagorean theorem. So let's get rid of this and move on to the next one. So here, it's not as easy to see. I'm actually going to take my camera and I'm going to move it a little closer so you see. All right. So I have these 3 points. You'll notice, even though I got these kind of marked off here, I didn't put any numbers. I drew some dots, but I'm not even going to actually go and use the actual coordinates. I'm going to use what it says here. Alright? So as you see, P says x1, y1. R says x2, y1, because they're on the same horizontal line. And then Q is x2, y2, because they're on the same vertical line. Okay? So, what I'm going to do, as it bounces around, okay, let me see now, let me move it a little closer. Alright. What I'm going to do is I'm going to start to draw this triangle. I'm going to connect the points. So, first thing I'm going to do, I want to find this diagonal distance. Okay? Because honestly, when I'm doing horizontal and vertical distance, if I have a line that's just straight up and down or straight left to right, it's not hard. I just count how many spots it is. Okay? And that's how long it is. So if I have something, if I use the real numbers, this is at 1, and the R is at 1, 2, 3, 4, 5, 6, 7, 8, I would just do 8 minus 1 and get 7. But again, I'm pretending like I don't know what the numbers are. So I'm going to draw a straight line as best I can, which is horrible. And that's what I'm going to refer to as PQ. The line is PQ. And I put a line over it, line segment PQ. And I'm going to label this side as D. Now I know we normally would label the hypotenuse C, but I'm doing this for a reason because what letter does distance start with? D. So we're going to use that there. Okay? So, then I'm going to draw the horizontal line from P to R. So I draw that straight across, and I would refer to that as PR, or line segment PR. That's what, if you don't really see it, but there's a straight line above that, and straight line above that. That tells me it's a line segment. It has a definite beginning and end point. And that I'm going to write as A. And then the last one, the vertical line, I'm going to do that connection. That is line segment QR, and we're going to make that RB. Okay? So, as you see, what I've made is a right triangle with hypotenuse PQ. Okay? I'll even put my little square in the corner there. Alright? Now, PR is our horizontal distance. Alright? So, you'll notice Y1, Y1. So I don't need to know what the Y's are. All I need to know is what's the difference in the X values. Since we're going to the right, this one is the larger X value. So what I can say is that A, our distance, this whole length of that side, is going to be equal to x2 minus x1. So whatever this x value is going to subtract this x value. But again, we don't know what those are. So in the case of our vertical line, the only thing that's changing is our y value. Again, this is x2 up here, this is x2 down there. They kind of cancel out. So again, we would just need to find what is this minus this. So I would say that B is y2 minus y1. Okay? So, where does that get us? Well, now we're going to go and we're going to do the Pythagorean theorem. But instead of it being a squared plus b squared equals c squared, well, we do have a, we do have b, but instead of c, we're going to use d. So, let me Okay. So I have d squared equals a squared plus b squared. Okay? So, the first thing I'm going to do is, I don't want to find d squared. I want to find d just by itself. So I need to take its square root. Well, the square root of d squared is just going to be d. But since these two are adding together, I can't just write a plus b. That doesn't work. So what I have to do is I have to just write it as I'm taking the square root of that sum. Okay? Now again, we don't have an actual value for a, but what we do know is that a is x2 minus x1. So what I'm going to do is I am going to substitute a with x2 minus x1, and whatever that difference is, I'm going to square that, and I'm going to add that. All right, notice parentheses around this because I'm doing whatever the difference of this is squared. So I have to do what's in the parentheses first. Plus, well, b, I said was y2 minus y1, so I'm going to replace it. y2 minus y1, and I'm going to square that. And this right here, I'm going to even write it bigger. Let me use my big chisel one. Is d equals, so the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Extend that. And that's the distance formula. That's how we derive the distance formula from the Pythagorean theorem formula. Okay? So now that we have this, we're going to we're going to use this, but what we're going to do is when we can see what we're subtracting, when we have a graph, we're going to still count. But what we're doing is we're really finding the difference between, our y's and our x's to see, well, what are the numbers that we're going to use. All right, fix that hair. All right, all original. So here, it's not that easy to see, but I have 2 points on here. Okay, this point up here is negative 8, 6. This point down here is 1, negative 6. And what I want to know is what is the distance, and let's see if I can draw this. What is the distance between those 2 points? Since it's diagonal, I can't count the boxes. I can't do it. All right? Because if I go, oh, this is 1 box, it's not. It's not 1 box. It's not the length of one side. It could be longer. It could be shorter. We don't really know. So what I'm going to do is I can use the distance formula, or again, I have a grid here. So I could turn this into a right triangle. Okay, so what I'm going to do is, I got my green one this time, and I'm going to go and make a line here, and I'm going to make sure I don't go too far. Okay, and then I'm going to go across. Okay, so now I have a right triangle. So what I'm going to do is I'm going to do what I've been doing. I'm going to go and use the Pythagorean theorem. I'm going to count, excuse me, I'm going to go and I'm going to count across and see how many spaces that is. I'm going to count up and down and see how many spaces that is. What I want to point out is if I'm looking, this point right here is 1, 6. Okay? Now, here's what I'm going to do. Okay? When I look at this, I'm starting at -8, and I'm ending at 1. Remember, we're looking for the positive distance. So I could do 1 because it's bigger, because it's positive. It's bigger than -8. So I would do 1 minus a -8. Minus a negative makes it a positive, so we would actually add those two numbers. So this distance is 9. Here, well, this is y value is at 6. Down here is -6. This is bigger. So 6 minus a -6. And again, minus a negative becomes plus. So 6 plus 6, this distance is 12. So we can go and plug that in. And what we really did was we found here's x2, here's x1. We did that subtraction. Here's y2, here's y1. We did that subtraction. Okay? So I've got a squared plus b squared equals c squared. I'm going to say 9 is a. So 9 squared plus 12 squared equals c squared. Now here's the thing. Let's say you did -8 minus 1. You would get a -9. When you put it in the calculator, you need to put parentheses around it. So I'm going to do that here as well. Just so we get into the habit of, let me make sure those parentheses around it. Here's why. Because when I put the number in parentheses, then automatically the calculator realizes I have to do order of operations. So, well, there's only one thing in the parentheses, so I can't do that. So exponent first. So it's going to square the number first. Now, in the case of a positive number, that's not a big deal. You know, whether I square it first or anything. The problem comes with a negative number, and I've said this to my students before, is that when you put a negative number in the calculator and you don't put it in the parentheses, the calculator sees a negative number as the product between a -1 and a positive whatever number it is. So first it will square whatever that positive number is, and then it will multiply by -1. So if I had this as a -9, if I didn't have those parentheses, my calculator would go and say, well, 9 squared is 81, and I multiply by negative. Once I put it in the calculator views it, and when you put it in the parentheses, the calculator says, oh, I'm squaring -9. So I'm doing -9 times -9. Negative times a negative gives me a positive. So as I said, this will be a positive 81. Okay? 12 squared is one of those that we all know. It's 144 equals c squared. Okay? We add these two together, we get 225 equals c squared. Take that square root, and we get c equals 15. Okay? Now, it's again, realize it's not always going to come out to a nice whole number. But if it doesn't, it'll tell you either to approximate to the nearest, usually tenth, sometimes hundredths, it depends on the problem, or it'll say write the exact value, which if it's not a perfect square, which 225 was, you would stop basically here, and you would leave this in the square root symbol. Okay? But this was nice. It came out nice. Let's go. And we got one more. Because we have what everybody loves, a word problem, which I had to write really small. So, of course, you think my handwriting is awful to begin with, and you all know that if you're one of my students. But what I'm going to do is I'm going to move this up a little bit. All right? So, see a little bit more down here. My handwriting in general is not good. It's awful. I always joke around that it's like a toddler in an earthquake. All right. So, but what I did was I drew, and I'm also not a very good artist. All right. Singing voice is amazing, but my drawing is not so much. So what I drew is I drew a lake, and what I have here is, you'll notice it's not graph paper. I'm going to do this again. I'm going to take you so you can actually read what I wrote. All right? So, I have here, Francesca wants to find the distance between her house on one side of the lake, here's her house, and the beach on the other side of the lake. Here's the beach. She marks? Yeah, I'm not from Long Island. She marks off a third point, forming a right triangle. So that's what we have here, as shown. The distances in the diagram are in meters. So as we look, her house is at 10, 20. All right. The beach is at 280, 164. And then she drew this third point at 280, 20. Okay? Hopefully nobody gets motion sickness. All right. So, I'm going to do this one. I'm going to show you how you can do this. It's still going to technically be the distance formula, but we're going to kind of, I want to actually put it a little higher. We're going to kind of cheat a little bit in that we're going to say, okay, well, I'm going to label again. I'm going to look for an A. I'm going to look for a B. I'm going to call the vertical A. I'm going to call the horizontal B. Okay? So what I'm going to do is I'm going to find out what is A. All right? So A, I'm looking for what is the difference in the y value. So we have the 164 and the 20. So A is going to be 164 minus 20. So A is going to be 144. I'll write that there. 144. Excuse me. B. All right, so B, the larger number is the 280 over here. So B is going to be 280 minus the x value over here is 10 minus 10, which gives us 270. So B is 270. Okay, so 144 meters going vertical, 270 meters going left-right. Okay, so what I'm going to do is A squared plus B squared equals C squared. All right. A was our change in the y's, y2 minus y1, which was 144. Put that in parentheses. Square is on the outside. To the second power is on the outside if you prefer that. And 270 here equals C squared. Okay? We're dealing with some big numbers, so hang with me. So I got 144 squared is 20,736, and 270 squared is 72,900. Okay? Like I said, big numbers. So we take these two, we add them together, we get 93,636 equals c squared. So as I said, now that we've gotten to this point, I need to know what c is. And I never marked c. C. Okay? So I'm going to take that square root of this ginormous number, 93,636. I'm going to change to a different color because you can't really see it. It's kind of like magenta. When I do that and I go on my calculator, as a matter of fact, I have the answer, but I'm going to show it to you again. So I go here. Okay, I'll clear that. Second square root. I've got 93,636. I don't actually have to close. Look at the reflection. I don't actually have to close the parentheses. So I hit enter. And look at that. It's a nice number. 306. Okay, so C equals, you can't even really say that either. Go back to the black. C equals 306. And remember, it's in meters, so I'm going to put M for meters. And that's how you use Pythagorean theorem / the distance formula to find distance. I hope this was helpful. I'm going to stand to the side so everybody can still see this. I hope this was helpful. Please make sure that if you are doing your work for my class, that if you need help, you make sure to comment on Google Classroom for me. As many of you have commented, I don't let comments in my YouTube, so for now that's the way it is. But if you do have questions, please make sure to comment on Google Classroom. I hope this is helpful. Please, as always, stay safe, stay healthy, and I'll see you next time.